Welcome back, EHS 300, and in this video we're going to focus on artesian wells, and we're going to discuss some examples of some well water testing that's been done in southeast Kentucky. And I'm going to switch over to the image of the artesian well design. And artesian wells are more common or typically more easily able to be constructed in mountainous or hilly terrain where you have the ability to have water get brought into the soil up here or up here, and then it finds its way underground into a porous layer that is often trapped between impervious layers. And when you tap into it, it will provide a pumpless water source that can bring underground water to the surface, provided that you're tapping into groundwater that is under positive pressure. So there's water elevation up here, water elevation up here, and it's trapped. So if you tap into it, it can come out of there. To give you a better representation of what's going on with this, I'm going to pull up a few videos that may be of some help.
Equally in a pool or within a system of pipes. The water table is the level it would reach if evenly distributed. Artesian wells are built where a porous layer of rock full of water lies between impermeable rock layers. If the porous layer is inclined, the water is prevented from reaching the water table by the surrounding impermeable layers. The higher the water table, the greater the water pressure. When a hole is bored to tap into the water source, the water rises up the well to reach the water table.
Okay, so I'm going to go ahead and I'm going to stop that video. There is another video that I'm going to show that might further help clear up this video to make it even easier to understand.
To put this another way, let's say you are holding a short hose full of water with both ends pointing up and one end higher than the other. If you pour water in the high end, the water will flow out of the other, lower end because the new water pushes it out. That's what's happening in the aquifer in the figure.
Okay, so additionally, on top of this, if you were to think of soil or ground occupying this space here, this could be a point of high elevation, and you have ground here covering this. You've got water that could come out of there, but you could also drill or put even a pinhole in the hose down here, and the water would squirt up all the way to that point if there's sufficient pressure. Sometimes people in the mountainous communities of eastern Kentucky may have a spring house on the side of the hill where the water seeps out, and they may capture the water there, and then they put the water through a tube down to their house, and then they might actually have a pipe come out of the ground here that brings them their water. So it's just using gravity to push the water out. Again, if you had soil covering this up, and this was too far away, and you lived here, you could drill down into this space and the water would come out all the way up to this point. So it's a real great opportunity for people to be able to get a continuous supply of water. So those are called artesian wells, and they are gravity fed. Other than artesian wells, sometimes we have water sources where there may be a hillside or a mountain and the water seeps out of the ground. Sometimes the water bubbles up out of the ground in some places, but it's generally easier to access when the water seeps out of the hillside. And many of these have houses or concrete structures built around them or pipes jammed up inside of them, so that the water comes out in a more solid way, and it's easier to fill up a bucket this way. So this is an example of an older spring house, and people would go there and get their water from these. So that's just an older example. Sometimes people will take their spring house up on the side of the hill and run the pipe from the spring house underground and then to a point where they might then pipe it like this gentleman did here in this video. I guess I don't have the video hooked up anymore. All right, so that's a little bit about spring houses. Now, the water in eastern Kentucky at different places has had a lot of folks sometimes concerned to drink it. The region's had a long history of mining and other mineral resources being extracted, including natural gas. The region, some folks not just believe, but the scientific evidence shows that cancer and a lot of other conditions are more common in the central Appalachian region compared to all other areas of the United States. Previous studies that have looked at smoking and income and diet and all of those things still said the frequency of illness in this region does not explain all the excess cancers and neurological diseases. And there have been some that have suspected that heavy metal exposures from drinking groundwater has potentially been a reason for the excess disease. And there have been numerous other studies since Dr. Schreiber's study, and he was a professor actually at, it was Prestonsburg Community College, now it's called Big Sandy Community College. So he did a study on arsenic a long time ago. Even at EKU, Andy Wigington, I think when he was at the University of Kentucky, he was a biology professor at EKU, they saw elevated levels of some metals in certain spots in the private drinking water in eastern Kentucky. And again, there's all of the health challenges that are sometimes linked to the region. And there has been some limited ability, though, to actually say that, yes, it's the water. It's hard to provide causality because many of these study designs just look at the cumulative number of cases of disease rather than actually looking at individuals and what they were drinking. So these are often flawed studies when you look at the health because it's focusing on everyone. There have been studies around the United States that have looked at manganese exposure in drinking water. This was in Environmental Health Perspectives about 7 years ago. That showed that manganese levels in Appalachian kids has been associated with decreased school performance. And most U.S. risk assessments for things like arsenic are based upon epidemiological evaluations and investigations. So there are some studies that still need to be done. So we had a hypothesis in our study when we actually surveyed a couple hundred people in eastern Kentucky that we thought that there'd be an increased risk of all kinds of health problems associated with elevated levels of heavy metals. And we actually measured the metal concentrations in household well water and obtained health information from a lot of folks. And we used the instruments that you've already used to a certain degree in the lab. And there's a couple former EKU students, Amber Kiddo and let's see, trying to remember. All right, and we have Ben Chariot and Peter Siglai, some of our former students, and that was Tabitha Owens back there. So what did they find? What did we find? Well, there are no private drinking water standards. Remember that, right? So remember, private drinking water systems don't have standards. So we can occasionally compare them, though, to the public drinking water standards. And the public standards are primary or secondary. Primary standards means that they're associated with health outcomes. Secondary standards means it pertains to them being more of like a nuisance, or they can stain or dye the clothes. So we saw elevated levels of iron and manganese that were secondary standard exceedances, meaning that it was so colorful or was so high that it would taste bad or look bad or could stain their clothes. So we saw a lot of secondary standard violations. Not violations, but exceedances. There are no violations because there are no laws on this stuff. And the reality of it is if your water doesn't look good or taste good, what impact does that potentially have on whether or not somebody's going to actually drink it or not? So that's one problem. And then on manganese, there used to be a health standard. It no longer exists. The World Health Organization and the EPA had a health advisory criteria, and many of the samples exceeded that. They've got rid of the manganese health advisory criteria. Lead was not all too common, but 11% of the samples had lead levels that had to be rechecked because they seemed to be a bit high. Arsenic was not very common, but 2.6% of the samples had arsenic levels that warranted further investigation. What was shocking to me was, 10% of our people ever having a history of cancer is not as shocking, but among the women who were 14 years of age or older, nearly 30% of them had reported having lost a baby. 13.5% of all the people, but among the women 14 years of age or older, almost 30% reported having ever lost a baby, which could have included miscarriage, or the child dying at birth. So there were several metals like manganese, arsenic, and lead that in some cases were a little bit higher. And again, that miscarriage rate was really concerning. And there may have been other factors, not the water, that could have been associated with that. We did not see a statistical relationship between this and any of the metals. But what I do know, though, is all the people we took samples from were well water users. So it may be something about the well water users in general that puts them at a greater risk. And lastly, EKU students were able to get a lot of important scientific data. So, and then these were all the folks that supported that particular project. So it's been a few years. So you all should be able to go through these review questions and have a pretty good understanding of private well water. So in this particular study, what were some of the heavy metals observed in high concentrations? So we were worried about iron, we were, manganese. They were elevated to the point that people may not want to drink their water because they were so high from a secondary standpoint. What metal is associated with cancer? So of the ones I mentioned, manganese, iron, lead, arsenic, which one's the one that's most associated with cancer? And the correct answer is arsenic. Does the EPA have enforceable drinking water criteria for well water users? And you should know the answer to that is no. And as we talk about what groundwater metal is associated with cancer, I'm going to pull up one last bit of imagery here for you to see regarding what happens when arsenic gets in the public or private groundwater system. So moving into arsenic contamination in groundwater. So this story says arsenic water killing 1 in 5 in Bangladesh. The World Health Organization calls it the largest mass poisoning of a population in history. And when I was at Ohio State, the president of Bangladesh came by invitation of Dr. Ratan Lal, who was up there as an expert soil scientist, and they explained how arsenic poisoning, because people needed access to water for their food and for drinking water, arsenic poisoning happened because people dug wells and helped them. International organizations helped get water to the surface, but when that water was brought to the surface, they didn't know or check and realized that it was contaminated with arsenic and essentially contaminated much of Bangladesh, especially the rural Bangladesh, with arsenic-laden water. To give you a perspective on how bad it is, here's the percentage of the wells, many of them were constructed, contaminated with arsenic. And you can see nearly 100% of them in this region of Bangladesh. And here is the capital, and this is the most populous region of Bangladesh. is contaminated with arsenic. It goes into their food supply, it goes into their water supply. It is truly awful. And then the health effects, beyond the cancer, kidney cancer, bladder cancer, lung cancer, liver cancer, arsenic has a number of other horrible effects on children, on skin lesions, skin cancer, cardiovascular system. And in that first image here, I show you this particular hand, and she displays her hand, and you can see all the black spots. Sometimes people have black foot disease, where the arsenic level causes all these black spots on their hands and their feet. And it's because of the vascular neuropathy or whatever, where the veins don't properly do what they need to do, and the blood vessels are damaged by the arsenic. So that's a little bit about arsenic, and it is a carcinogen, and that's a little bit about groundwater problems gone wild. So those were the last slides I had on this particular topic. We're going to move into private water supply needs and cisterns, and how to treat water on your private property in these next videos.